Hey guys, this is the review for our quiz before Thanksgiving. Um, and I'm just going to add on here, since it's something we've been practicing, that you solve. And what that's going to mean is find the zeros. So just like what we've been doing. Actually, no, that's what the back part does. So JK, we'll just do what it says. Okay, so factor review. Keep in mind that what you always want to check for first is the GCF. You gotta check first. Is there a greatest common factor? And then you decide if there's 2, 3, or 4 terms. Then you want to look, if it's 4, you want to look at grouping, where you split it down the middle. 3 is where you unfoil, like we practiced last time. We learned how to do it if the number out front was equal to 1 or was not equal to 1. And then with 2, the only way that we're able to factor it further is if it's 2 squares that are subtracted. Then we find what things got squared, and we kind of unsquare them, and then the factors become their sum and difference. So those are kind of the only tools we have in our factoring toolbox, so let's go for it. Here I have 2 terms. So the first thing I look for is a greatest common factor, and I can see that 7 goes into both of these numbers, and they each have an x as well. So if I was going to take a 7x out front, what you're really doing is dividing that out of each piece. You're like undistributing it. So 14 over 7 would become a 2, and you had 2 x's and you took 1 out, so there would be 1 left. Here, 21 divided by 7 is a 3, and you only had 1 x, so when you took it out, you were done. So those are the factors, and this part's not asking us to solve, so we're done. Now the next one has 3 parts, and there's nothing that all 3 have in common, so I just need to unfoil it. So I go to my yellow sheet, and my ways to make 21 are 1 times 21 and 3 times 7, and I need them to subtract to be 4. And you'll notice there's a 1 out front, so I don't have to worry about that like little trick I showed you. So the only way that you can get the 21 and subtract to be 4 is to use 3 and 7. And then in order to make a positive 4, I would need a positive 7 minus 3. Done. Same thing here. I have 3 terms, so I unfoil. Here's a 1, so I don't have to use the trick. There's only one way to make 5, and it adds up to be 6, which means this is factorable. So 5 times 1 makes 5, and it will add up to be 6, but I need the 6 to be negative, so they both have to be minus, because a negative 1 minus 5 more would land me at the negative 6. So then that's my answer. These are my factors here, and these were my factors here. This unfoiling is by far the most common, so that's why you see it so much on this sheet and within your regular work. I'm looking at my yellow sheet and I'm seeing all the ways to make 16. And then I realize I need one that adds up to be 8. So the one I need to choose is 4 and 4. And in order to get a positive 8, they both have to be plus, and I'm done. Here, same thing. I have 8 again, so 1 and 8, 2 and 4. They need to add up to be 6. So the only possible combination is my 2 and 4. And in order to get a positive 6, I'd need a positive 4 plus 2 more. Plus, keep in mind, anytime you see that this last sign is positive, positive tells you that you're going to have the same signs in your 2 factors. So like here, this is a plus, so they're going to be the same, and you can see they're both positive. This one was a plus, so they're going to be the same, and you can see they're both negative. This one was a minus, so that means they're not going to be the same. You're going to have one of each, and so I have a positive and a negative in my answer. So it's just another way to kind of know what to expect. Like here, this is negative, so I expect that when I'm done, I'm going to have different signs, 1 plus, 1 minus. Okay, so I have a 1 out front. Don't have to worry about the trick. 10 on my yellow sheet is 1 and 10 or 2 and 5, but the only one that subtracts to be 3 is going to be the 2 and the 5. So I'm going to use those. And then in order to get a negative 3, I would need a negative 5 plus 2. So I ended up, like I expected, with different signs, a positive and a negative. This only has two pieces that doesn't have anything in common, but this is the perfect square of x and 25 is the perfect square of 5. So this is the difference of squares and it breaks down into the sum and the difference of the square root of each part. So that's just a factoring pattern. Keep in mind that anytime you're not sure, you could FOIL it back out. And so these two would multiply to be x squared. This would be a minus 5x, and this would be a plus 5x. And then this would be a minus 25. So that's how you end up with two pieces. We usually, when we FOIL, we get three pieces, but in this kind of problem, the middles cancel out. So you can always check your factors by FOILing them out, and you should end up back where you started. This one, I'm looking to see if they have anything in common, and they don't. But this is this perfect square of 3x, because if I took 3x times 3x, I'd get 9x squared. This is the perfect square of 7. So then I'm going to use my difference of squares pattern and use the sum and the difference of those two things. And the reason I know to do it that way is that there's only two pieces. There's two parts instead of three. So like here I have three pieces. What do I know? I know that this is positive, so I'm expecting to have the same signs. And then I go to my chart and I try to find ways to make 49. There's not very many ways. There's 1 in 49, 7 and 7. And the way that will add up to be 14 is 7 and 7. But to get a negative 14, they both have to be minus, and I'm good to go. Okay, I have two parts here, but see how it's adding? So it can't be the difference of squares because the difference is subtraction. So what I'm going to look for is something they have in common. So I can see that they would both divide by 3, and they can both give up 1x, not 2, because this 12x only has 1. So that becomes my greatest common factor. 9 divided by 3 is 3. When I take out 1x from the x squared, I have 1 left over. Here, 12 divided by 3 is 4, and these x's cancel out entirely. So then this is my factor. Okay, now we have the number in front. So now we're going to do that thing where if there's a number here, I put it here and here for now, and I'll have to reduce later. Then remember, this is a part that's hard to remember too. This has to be the 12 comes from the front end times the back end, and then that's the number that you split using your yellow sheet. 1 and 12, 2 and 6, 3 and 4. I need them to add up to be 8 in the middle, so I pick 2 and 6. Doesn't matter where they go. And then now I need to figure out how to make them both be, how to make it be negative 8, so they both have to be minus. And then since we sort of made the numbers bigger, we do have to reduce. They both actually reduce in this case. They both can reduce by a factor of 2. So if I cut this in half, I get 2x minus 3, and the second one becomes 2x minus 1. I see here there's a 4, so I'm going to have to put it at the beginning of each of my factors. So 4x, 4x. Multiply the front and back end. That's the number I'm going to split. My options are 1 and 4, 2 and 2, and they have to add up to be 4. So I'll need to pick 2 and 2. In order to get a positive 4, I'll need plus 2, plus 2. Time to reduce. You always have to reduce in this method. So both of them reduce again. If I cut this in half, each piece, I get 2x plus 1 and 2x plus 1. So these are my factors. Okay, looks like the same thing because I have a 3 here. So I'll need a 3 at the beginning of both of my factors, and I'll have to reduce later in the problem. 3 times 8 is going to give me a 24. So on my sheet, I have a lot of options for this one. But I need one that subtracts to be 10, not adds up to be 10, subtracts to be 10. So that's going to be these two. So I need a 2 and a 12, and I need it to be positive 10, which would be a positive 12 minus 2. And then I always have to reduce with this method, but in this problem, only the first one has a common number that you can divide by. So if you divide 3x by 3, you get x. If you divide 12 by 3, you get 4. And the second one does not reduce. So then these are my two factors for this one. Okay, this has 4 terms, so I'm going to chop it down the middle and do grouping. Here, this side has a common factor of x squared. They both have 2 x's to give up. If I take 2 out of here, I'll be left with 1. And if I divide 2 out of here, they'll both be gone. Over here, this is tricky. This negative pulls out, and then they both can have a 4. But if you divided this by -4, you would get x, and then you have to divide the negative out of this as well. Plus, remember that these two pieces need to be the same. So this one's kind of tricky, because now this becomes something they have in common, so that comes out front. And then these 2 other remaining pieces become the other factor, but this one is now the difference of 2 perfect squares. X squared is the square of x, 4 is the square of 2, so that one breaks down one more time into x plus 2, x minus 2, using the difference of squares. And then I'll stop after this, so there's 2 different videos. Here, again, I can take out an x squared. This x cubed would lose 2 but keep 1, and the 6x squared would lose both. I wrote over it, but this is a positive here, so I don't have to worry about the pulling out a negative. But if you divide 5x by 5, you get x, and a -30 divided by 5 is x minus 6. So these become this common term, and then that leaves me with x squared plus 5, which can't break down farther because it's adding, not subtracting. And if you have 2 pieces added, they never break down. So that's at least a video for the front. I'll make a separate one for the back where we find the zeros as well. Hope that helps. Bye.